There's no way around it. We need to push innovation and increase the development of cleaner, renewable sources of energy and reduce our dependence on fossil fuels.
Yet, no single technology can accomplish this challenge on its own. We need a mix of sustainable options.
What if one of the most predictable, untapped sources of clean energy already exists and is right off our shores? How do we harness this ocean of energy? Hey everyone, I'm Tyler. And this is my younger brother, Alex.
And together, we're the Water Brothers. We're going to take you on an adventure around the world to explore the state of our blue planet, a planet defined by water and its ability to sustain life.
So join us on our journey as we explore the world, looking at the most important water stories of our time.
And together, we will learn how to better protect our most precious resource.
Tides and waves have been stirring the ocean ever since it formed around 3.8 billion years ago. Anyone who has witnessed the huge ebb and flow of tides or surfed a gigantic wave can attest to the incredible energy flowing through the ocean.
The possibility of converting the power of waves and tides into electricity has enticed generations of scientists and engineers. Yet, the ocean had been too volatile and the technology too expensive to compete with conventional sources of electricity.
Now, as the impacts of climate change are becoming more severe, these endlessly churning waters are being reconsidered as a viable source for renewable energy generation.
The main advantage is that it's predictable. With wind and solar, it's obvious at night there's no sunshine. With the wind, you sometimes get calm periods. With tidal, though, the tides are driven by gravity, not by weather. And the gravity forces of the moon and the sun interacting with that of the Earth are absolutely mathematically predictable far into the future. So unlike the other intermittent renewables, the output from a tidal turbine is very predictable. And that's actually quite a big advantage.
With its rugged coastlines and rough seas, the waters surrounding the United Kingdom are considered a perfect location for marine renewable energy generation. And as a result, the UK has emerged as the birthplace of this exciting new industry.
In a small town just south of Belfast in Northern Ireland, a fully operational tidal turbine located in Strangford Lough has been supplying electricity to the local grid since 2008.
Today we've come to the town of Portaferry to see this, the CGen device, the world's first commercial-scale tidal turbine.
The day we arrived, CGen was undergoing regular maintenance, giving us a special look at the turbine blades above the water.
So Matt, tell us about the CGen device. What makes this machine so unique?
Well, it's a tidal turbine generator. It's rated at 1.2 megawatts and it was installed in April 2008. And it's had a presence in the water since then and is commercially selling electricity and exporting the power into the grid in Northern Ireland. Fundamentally, the energy is captured from the large rotor blades that you see. That produces a lot of torque and turns a hub at about 14 RPM, so relatively slowly. We then have a gearbox which increases that to 1,000 RPM, which turns a generator, which generates electrical power. And that is simply fed into the grid.
So it's more or less like a wind turbine underwater. The blades even look like wind turbine blades.
It's exactly what it is. That's the best way to understand how the machine works.
CGen can generate 1.2 megawatts of electricity, enough to power over 1,000 homes. However, the strength of tides varies throughout the year, so the amount of electricity generated also varies.
It's amazing to think that the rhythms of the ocean are influenced so strongly by forces millions of kilometers away from Earth.
As the Earth spins, the gravitational forces of the sun and moon pull on the ocean, raising the sea level. Being much closer to Earth than the sun, the moon's gravity has a more dominant effect. As the moon pulls water away from the Earth, a high tide occurs on both sides of the planet, as the Earth is also pulled towards the moon, creating the opposing high tide bulge.
We just pulled up alongside the CGen, and being underneath it, you get a really good sense of just how massive this machine is and how powerful the tides are here. The water's just rushing past right now, but this is only a neap tide, so it's only about half as powerful as the tides we'll get here.
When the sun and moon are perpendicular to one another, the difference between high and low tides is at its lowest, creating neap tides. But when the sun and moon's gravitational forces align, the difference between high and low tides is at its greatest, causing spring tides.
Engineers have to take all these variables into consideration, including the fact that tides are influenced by geography and can become more pronounced in certain coastal areas like Strangford Lough, where features such as a narrow inlet and shallow water make the height of tides and speed of the currents even stronger.
All these factors help make tidal energy very predictable. But one concern with tidal turbines is the possibility that the spinning blades will strike marine life. So in response, a wildlife monitoring program has been set up with a local university.
If there's any reports of any of the dead seals been washed up on the shore, we've had to lift them and bring them up to the local veterinary clinic in Belfast to get an autopsy to prove the fact that CGN actually isn't doing any harm. And out of all the ones that we've brought out, there hasn't been one come back yet to say that it's been harmed by CGN. It's been natural causes.
It's believed that due to the slow rotation speed of the turbine blades, it's very easy for animals to avoid being struck. Actually, maintenance engineers have noticed some positive impacts on marine life.
CGN's now turned into an artificial reef. There's a mussel bed growing really on the structure of CGN, which again is inviting more invertebrate life to grow there, which invites the bigger animals to come and feed on those and the bird life.
And makes a nice dinner for us in the evening as well. As you're going off, grab a handful of mussels, just as you're going ashore. Can't get them any fresher than that.
The CGN machine has proved that the actual concept works. It's taught us plenty of lessons along the way, which we've been able to learn from and rectify and get the machine running again. So it's been a really, really good learning experience, and we think that that'll be the springboard into wider deployment of this technology with farms coming up in the near future.
The success of this enterprise is a positive sign for the tidal energy industry. And to get a sense of what the future holds for these technologies, there is no better place to go than the remote Orkney Islands in Scotland.
People have been living in Orkney for over 8,500 years, and ancient Neolithic sites are scattered across the islands. But today, the islands are gaining international attention for the development of state-of-the-art energy technology. Orkney's exposed, rugged coastlines with strong currents and winds make it the perfect home for the European Marine Energy Centre, or EMEC.
Starting in 2003, companies from around the world have descended on Orkney to test prototypes for harnessing marine renewable energy, like this tidal turbine. EMEC has built infrastructure so that devices can be connected to the local power grid, helping Orkney become 100% powered by renewable energy.
I mean, we've done it. We've done it here. You know, we generated from wave energy in 2004, first time anywhere in the world that had been done. 2008, we had a turbine here generating from the tides, first time in the UK. So, you know, we split people apart from those who don't believe it's going to work and those who do. And now we've actually shown that it really is working.
Technologies at EMEC come in all shapes and sizes, and some of the most fascinating and unusual designs are the many devices used to capture wave energy.
So we loaded up the boat and we're about to go see the Palamis wave energy device. And we're really excited to learn how this machine is able to harness the power of waves.
Joe Thompson is the operations engineer for the Palamis P2, a wave energy machine appropriately named after a species of sea snake.
So how does the machine actually capture wave energy?
So as you can see here with the machine, it's got 4 joints on it, and as the wave moves along the machine, it moves the separate sections and the joints move like this. And in each joint there are 4 hydraulic rams, which will then be moved in and out various points on the machine. It can also move side to side. And they pressurize oil, which then is fed through generators on the machine. So the machine generates electricity on board and conditions it, and then sends it via a cable, which goes along the seabed back to the land, back to the substation.
So it's connected to Orkney.
Yep, this is generating electricity to the national grid right now. This machine here is rated for 750 kilowatts, which means it can generate up to 750 kilowatts at any time, which you could probably compare to a sort of medium-sized wind turbine.
The Pelamis is able to power as many as 500 homes. And this latest version is being pushed to the limits in the turbulent sea conditions of Orkney to determine just how efficient this technology can become.
So what makes wave energy such a great form of energy to capture?
The waves often come at a different time to the wind, so when you've got wind power, you will have wave power, but when the wind goes away, the waves will probably still be there for quite some time. So you can rely on the fact that you'll have a good mix of energy, which helps for energy security.
Although wave behavior is inconsistent and harnessing wave energy is economically challenging, Northern Scotland remains a perfect place to further advance this promising technology.
And I hear that when you're not working on the wave power device, you also like to play in the waves as well.
Yeah, I'm an avid surfer, so I work and play in the waves. I've been surfing for 12 years. And I suppose that's part of the attraction of working in wave power is you get to be by the sea. What's the better way to find out what the power of the waves is than go out in them yourself?
Oh man, that was so much fun. I'm exhausted. Being out there getting pummeled by the waves really does show you though how powerful wave energy really is. And it's amazing to think that the waves we are riding have come all the way from the other side of the Atlantic, thousands of kilometers away. It's such a massive source of renewable energy just waiting to be harnessed. Imagine if we could capture just a fraction of it.
EMEC plays an essential role helping companies optimize their designs for widespread deployment. But before machines can be tested in the ocean, devices are put through their paces at the smaller, model-sized scale. So we went to the University of Edinburgh to check out the FlowWave, the most advanced marine energy test tank in the world.
FlowWave's CEO, Stuart Brown, was on hand to show us how the world's most expensive wave pool is able to create both waves and tides at the same time.
With its unique circular shape and 168 wave makers working in tandem, the FlowWave can push waves and currents towards devices from every angle, mimicking stormy seas.
This is effectively like a stepping stone. When you have small-scale testing, maybe 100-scale models to test and prove concepts, it's a huge leap to go from there to testing something that's in steel in the real sea. It's expensive in terms of the consenting, in terms of the vessels you need to hire and so on. So this is a way of testing at large model scale to refine those devices, to get the risk out, and basically make your mistakes relatively cheaply behind closed doors in a very controllable way.
To give us a sample of just how powerful and precise the machine is, they showed us how they pushed the FlowWave to its limits to create a 1-ton blast of water capable of crushing a car.
Wow.
How cool is that?
That's so cool.
It's a very sophisticated instrument. It's a huge piece of engineering, but most importantly, it really will solve some of those big industry challenges and issues about performance, about reliability, and that leads into bankability and financeability as well.
With tidal and wave energy technologies still in early stages of development, the initial costs can be expensive for developers and consumers. But these costs must be weighed against the often unaccounted for benefits of reduced air pollution and its effects on society.
But as testing facilities like FlowWave help increase efficiency, and as more devices are installed around the world, costs are expected to fall quickly. The next big challenge is to determine just how widespread marine renewables could become.
We don't accurately know how much tidal energy there is because most of the locations where there are possibilities have never been surveyed properly. We do have a pretty good idea of the UK's resource, and we think it's in the region of about 10% of present-day electricity demand. That would equate to about 5 to 10 gigawatts of installed capacity. And I believe the rest of the world is probably, to give a very round number, about an order of magnitude more. In other words, about 10 times the UK. And you may be interested, I think, the other country which has a particularly good resource is Canada.
With the world's longest coastline and countless inlets and bays, Canada is a perfect fit for a tidal energy industry. And the most exciting location being studied today is the Bay of Fundy, home to the largest tidal ranges in the entire world.
People have been trying to think of ways to generate electricity from the Bay of Fundy for well over 100 years. But it wasn't until 1984 that Nova Scotia built this, the Annapolis Royal Tidal Generating Station. It's called a tidal barrage system, and it works a lot like a hydroelectric dam. But these systems have a few limitations. There are very few places you can build them, and when you do, they sometimes trap marine life that swim through the gates. But thankfully, tidal technology has come a long way in the past 30 years, and Nova Scotia is on the verge of revolutionizing the way they generate electricity from the tides.
Thanks to advancements made at research facilities like EMEC, in-stream tidal turbine technology finally seems ready to take on the challenge of harnessing the most powerful tidal system in the world.
The record-breaking Bay of Fundy tides are a result of its unique shape and depth, forming a funnel-like structure that is just the right length to maximize tidal range. As the high tide flows into the mouth of the bay, it takes roughly 6 hours for that water to flow to the tip of the bay and back out again, matching up almost perfectly with the ebb and flow of tides across the Atlantic.
The difference between high and low tides in parts of the bay can be large enough to cover a 5-story building. And during the 12.5-hour tidal cycle, over 115 billion tons of water flow in and out of the bay.
The amount of water that's going through there, we calculated when it's flowing at flood tide, is roughly the same amount of water as all the rivers in the world combined. So right outside in Minas Passage there, we have more than the Amazon. It's about 2.5, 3 times what the Amazon River is flowing at any given point. So this is a huge amount of water going through there.
This massive movement of water and nutrients supports a rich ecosystem of fish, crustaceans, mammals, and millions of migratory seabirds.
There are so many amazing natural wonders to see in the Bay of Fundy, but one of the coolest ones to experience is known as a tidal bore. And this occurs when the tides meet large rivers. And when these two forces of water meet, they create massive waves that people love to whitewater raft on. So today we're gonna get out in the water and experience the true energy in the tides.
The Shubenacadie River near the city of Truro, Nova Scotia, hosts one of the most unusual river rafting experiences in the world. Twice a day, a tidal bore forces its way up this river system for over 30 kilometers and is so fast and powerful, it can only be ridden for long periods using a motorboat.
Even though it is too shallow here to capture the energy of this tidal bore with a turbine, it is a perfect example of just how powerful the Bay of Fundy tides are. With so much energy flowing right through the backyards of over 1 million Canadians, it might seem surprising that a tidal energy industry hasn't already taken off here. But the incredible strength of these tides presents a significant engineering challenge.
One group that is helping make this dream a reality is the Fundy Ocean Research Centre for Energy, also known as FORCE, located near the town of Parrsboro, Nova Scotia.
We met with Matt Lumley, who took us to the site where FORCE is planning to install tidal turbines that will be hooked up to Nova Scotia's power grid.
So we're right near the test site, and this is Black Rock, you were saying, and you can just see the water rushing right by us.
Yeah, it's incredible. Right now, we're going 6 or 7 knots just to hold station. So, in other words, we're burning all this fuel to stay in one place, and effectively what tidal energy is doing, with an underwater windmill anchored to the sea floor, is collect all that energy.
In 2009, Nova Scotia's first tidal turbine prototype was deployed at this site, but engineers underestimated just how powerful the tidal currents really were.
It lasted through one spring tide, and then on the second spring tide, actually the second biggest spring tide of the year, the blades blew out. So there in a nutshell is both the challenge and the opportunity. We're working with a site that has equivalent to Class 4 hurricane tidal currents, so enormously powerful. But also, if you can harness that energy, the potential here is rich. And as we've developed the site over the last few years, we now have a much better understanding of what you really have to design for.
So if you can get a turbine to work right here, you can get it to work anywhere, really.
Yeah, our goal is to see 20 megawatts in the water by 2020. Nova Scotia's goal is to tender for an additional 300 megawatts starting about that time. And the actual power potential is up around 2,500 megawatts. And that's larger than the greatest peak demand in Nova Scotia.
So more power than all of Nova Scotia currently uses at their peak demand.
Exactly right.
Wow.
The work being done by Force is essential for helping Nova Scotia meet its goals for tidal power generation. But Force is not the only group working to make these dreams a reality.
Greg Trouse is an engineer for Fundy Tidal, a company that is planning to install smaller turbine projects that would be owned and operated by coastal communities themselves. We joined him for tests at a potential turbine site.
So Greg, tell us about these devices here and what we're going to be doing today.
Okay, these are low-profile surface drifters. So we'll put these in the water. It's got a GPS in it, and it's going to measure flow speed and direction all along its track. So what we'll do is we'll deploy them across the channel here, and then we'll pick them up downstream and repeat that through the tidal cycle. So it gives us really good spatial coverage.
So it's going to help you determine like where are the best places to put a turbine in the future?
Yeah, absolutely. It helps with that. Among like all the different devices that we use to measure flow, this is one of the cheaper ones that we use early on, but it's really useful throughout the site assessment process for giving us a really good understanding of the big picture of what the flow is doing through the channel.
And there's a lot of potential, like there could be a lot of electricity generated right here?
Oh yeah, absolutely. I mean, we're not trying to generate electricity to power Halifax or anything like that, but to power these communities, right? So it's really about local power production and local power use, and there's probably way more in this tidal channel here than the community could ever use. So we really think we can take out an amount to match community use so it's sustainable and doesn't have a big effect on the tidal channel itself and the marine life that uses it.
With turbine sites already being selected and many technical challenges being overcome, it now appears that the only major obstacles that will limit the total number of turbines that could be installed are the potential environmental impacts on marine life that feed and migrate in the bay.
At the present time, I don't think we're in a position to say what that limit would be, because we know so little about the effects of these individual turbines, and similarly, the effects of an array of them. So the strategy is we will do it incrementally. Put out the turbines, find the ones that will work and survive in that environment, and all the time monitoring what the effects are so that we can come to a point in which we say, we're approaching a stage in which there will be negative effects, and therefore that would be the time in which we put a cap on it. We don't want to trade off the richness and the attractiveness of the Bay of Fundy for energy. If we can take energy out of it without significantly changing the ecosystem or affecting the life that's in it, then that makes tidal power a very attractive opportunity.
We don't have the luxury that we had in the past of just using one major source, just coal or just oil or just gas, because they all pollute for a start, and also they're running out in some cases. So, you know, if we're going to use renewables, they all have their pros and cons, so we need to have a mix of clean energy resources. It's really a matter of having as many weapons in our sort of arsenal as we can to produce energy.
Marine renewable energy is more than just a pipe dream. It's already helping Scotland meet its targets to reduce greenhouse gas emissions. And now it is time for Canada and the rest of the world to follow in their footsteps.
While tidal and wave power won't be able to satisfy our energy demands on their own, they can definitely be an important part of the solution.
Renewables may cost us a little bit more on our electricity bills, but it's not nearly as costly as the untold economic price of climate change that's already upon us.
The best part is that the technologies already exist. What we need now is an informed and excited public to help government and industry harness this ocean of energy.
Join us and dive deeper into the episodes at thewatorbrothers.ca.